Okay, welcome to section 9.2, and in section 9.2 we're going to be talking about how to add and subtract rational expressions. We've already simplified single expressions, we've done multiplication and division on them. Now I want to talk a little bit about adding and subtracting. And the good news is the concept of adding and subtracting a rational expression isn't really that different than when we added and subtracted fractions in grade school. The whole idea is going to be getting common denominators. Okay, and when that happens, all you're going to do is you're going to add or subtract your numerator. So let's talk a little bit about how we're going to do that. So first, let's talk about how we can find these common denominators, or as you know from grade school, an LCM, which stands for the lowest common multiple. Okay, so we'll start with a pair of monomials. It's very simple. When you have something like 12y squared and 6x squared, you just take the LCM of the numbers, so in this case that's going to be 12, and then you kind of smush together all of the powers of variables. Okay, so you get 12x squared, y squared. If these two terms shared the same variable, then you would just take the higher power as your LCM. Okay, but now what if we have something like a pair of polynomials? I have 3x minus 6 and x squared plus x minus 6. That's where these steps here come in handy. So that what they tell you to do is they tell you to factor each polynomial. So the first polynomial we can take out a GCF of 3. The second polynomial, x squared plus x minus 6, that one's going to take a little bit more thinking. We got to come up with a pair of numbers that multiplies to negative 6 but adds to 1. So positive 3 and negative 2 will do that. Now to take the LCM, what you do is you write all of the uncommon factors that these two polynomials have. So in this case, there's a 3 that only the left polynomial has as a factor, and there's an x plus 3 that only the right polynomial has. So we put that together to form our LCM. And then we take any of the common factors and count them only once. So in this case, x minus 2 is a common factor, so we list it only once. So this would be my LCM. This is what I would have to get if these were my two denominators. If you had something over 3x minus 6 plus something over x squared plus x minus 6, you would have to get both of those denominators to look like this in order to actually add them. Okay, I have some examples of these in the note sheet to try. Just give you a pair of polynomials or monomials and find some LCMs. So pause the video at this point. Feel free to rewatch my explanation if you need to. Try this on your own, and then when you're ready, pick the video back up and we'll start looking at actual addition and subtraction problems. Okay, so now we're going to put this idea of finding an LCM together with an actual set of rational expressions to add or subtract. So here's a first example. 2m over m minus 3 plus 2m over m plus 3 plus 36 over m squared minus 9. Okay, so we want to first come up with what the LCM is going to look like. So let's factor all the denominators. The first two are already in factored form. But m squared minus 9, that's a difference of two perfect squares, m minus 3 and m plus 3. Let me erase that so you can see it clear. Okay, so let's take the idea that we have. Okay, so it looks like the LCM would have to be m minus 3, m plus 3, because if we take all the things that these fractions have in common and write them once, we write an m plus 3 for the last two fractions and an m minus 3 for the first and the third. So that's got to be our LCM. So my goal now is to get every one of these three fractions to have that denominator. So we look at what's missing from this list in each fraction, and that's what we're going to multiply that fraction by. So then let me use a different color to show you that I'm multiplying. So for the first fraction, I'm missing the m plus 3 part of the LCM. So that's what I'm going to multiply it by. So now my new first fraction becomes 2m squared plus 6m over m plus 3, m minus 3. And I just distributed the 2m into the parentheses. Now for the second fraction, the thing I'm missing is m minus 3. So I'll multiply that. And now my second fraction, when I distribute the 2m, looks like 2m squared minus 6m over m plus 3, m minus 3. The third fraction already has the LCM in it, so we don't need to change it. It's going to stay 36. I just rewrote the bottom to be in factor form so I can really tell that every denominator matches. Now all that's left to do is add. So 2m squared plus 2m squared gets me 4m squared, plus 6m minus 6m cancels, and then plus 36. Okay? If you want, you could factor a little bit further just to see, can I reduce? I can't, because m squared plus 9 isn't factorable any further. So we stop there, and that's our final answer. Let's look at a subtraction example. So we've got x plus 10 over 3x minus 15, minus 3x plus 15 over 6x minus 30. Okay, so again, for starters, we want to come up with what the LCM is going to look like. So let's factor each denominator. So the first denominator, I can pull out a 3, and I'm left with x minus 5. The second denominator, I can pull out a 6, and I'm left with x minus 5. Okay, so what do they have in common? They have an x minus 5, so that's got to be in my lowest common multiple. Now let's just deal with the coefficients that they each have. I have a 3 and I have a 6. The LCM of 3 and 6 has got to be 6. So I got to get both my denominators to look like that. This one's a little bit of an easier problem because one of my two fractions already has the LCM. So all that I really have to do is multiply the top and the bottom of the left fraction by 2, and then I get my 6x minus 30 that I want. So I'll distribute the 2 up top. I get 2x plus 20 over 6 times the quantity x minus 5 minus 3x plus 15 over the quantity 6 times parentheses x minus 5. Okay, now when I subtract, biggest thing I've got to worry about, distributing my negative sign. 2x minus 3x is negative x. 20 minus 15 is minus 5. Plus 5. 20 minus 15 is positive 5. Over 6, x minus 5. Now you might think you're done, but look at the top. I can factor out a negative 1, and I'm left with x minus 5 over 6. X minus 5. The x minus 5 terms can cancel. This one actually simplifies to a rational number, negative 1/6. Okay, let's look at one more. This is kind of as nasty as it's going to get. I've got two trinomial denominators, so I'm going to have to do a lot of factoring to come up with what my LCM is going to look like. So let's start by factoring y squared plus y minus 12. So I want two things that multiply to negative 12 and add to positive 1, so I believe that's plus 4 and minus 3. I'll do the same thing with y squared plus 6y plus 8. Two numbers that multiply to 8 and add to 6 are y plus 4 and y plus 2. All right, so let's get our LCM. Let's do the same kind of game we've been playing. Let's start with what they have in common. They have a y plus 4 in common, so we'll only write that once. And then we'll put all the things they don't have in common. Y minus 3, the left term only has the y minus 3, and the right term only has the y plus 2. So I got to get both my fractions to have that denominator. So what I'm going to do is I'm going to look and see what's missing from my list, and that's what I'm going to multiply each fraction by. So the first fraction is missing a y plus 2, so let's multiply the whole thing by y plus 2. The second fraction is missing a y minus 3. So let's subtract or multiply all that. So when we distribute across, I get 3y plus 6 over y plus 2, y plus 4, y minus 3, minus 2y minus 6 over that same bunch of factors in the second denominator. So now I can combine. Again, you've got to be very careful about distributing your parentheses. 3y minus 2y will be 1y. 6 minus negative 6 is really saying 6 plus 6, so I get 12. So I have y plus 12 over y plus 2 times y plus 4 times y minus 3. And that is going to be your simplified form of that difference. I can't cancel because I don't have any 12s. So this factor y plus 12 will not cancel with anything else. And that pretty much wraps it up. You have a couple of examples in the notes that I want you to try on your own. Feel free to watch any parts of this if any of the demo didn't make sense the first time around. Bring any questions to class, and we'll make sure to go over a lot more of these when we meet again. Okay? Thank you very much for watching, and have a good one.